Okay, so tell us your name and tell us about your project.
Okay, so my name is Cody Huff, and I'm just going to talk a little bit about this project that me and Sir Arthur Eddington are doing. So, me and Eddington are good friends, and so we teamed up to do our solar eclipse observation experiment. Me and Sir Arthur Eddington traveled to the southern hemisphere to observe a solar eclipse. So our experiment consisted of using a telescope to take pictures of the stars around the sun. So we aimed the telescope at the edge of the sun, and we took pictures. And then after that, we took another separate picture with the sun not present. So then we compared the two pictures together to see if there was any difference.
So what were you guys trying to do or find?
Okay, so the main point of the trip was to test Einstein's general theory of relativity. That was published 4 years earlier. His theory said that light could be bent around massive objects. According to him, light would be forced to bend in order to follow the curved space-time that surrounded the massive object, because the bigger the object, the more it warps the space and the time around the object. So this theory went against the popular concept of gravity, and that was that space and time and light were like a constant; they couldn't really be changed; they were absolute. So we just wanted to see if he was right, and if we after looking at both of the different pictures, one of the pictures looking at the eclipse, the stars from the side of the eclipse, and the other picture without the sun present, and we compared them. If there was like a difference between them and what kind of stars we saw, it would prove that his theory of general relativity would be correct. Because if we aimed the camera at the massive object and we saw stars that we shouldn't have been able to see behind it, then that would prove that light was bent, and therefore his theory of general relativity would be correct.
So where'd you guys do this project or experiment?
So the experiment was done. We did it with two teams just to make sure we'd have the best odds of capturing this, because eclipses don't happen every like so often. They're pretty rare. So the first team went to Sabra, which is north of Brazil, and the second team, that was led by Eddington and me, we went to the Principe Island, which is off the coast of Equatorial Guinea.
Okay, so what other events were happening around the world at this time?
Well, so this was around, this was in 1919 when we did this experiment. There was actually a lot of things going around during this time. So World War I had pretty much ended, and Nazi Germany was pretty much stopped at this time. And so the Treaty of Versailles was being signed around this time. And this would be like a written confirmation of peace between the nations. Another significant event that was kind of going around was the implementation of the 18th Amendment. And so that pretty much prevented the selling of alcohol. So there was actually a lot of different things going around during this time.
So who else was involved in this project?
So I guess I'll just kind of list kind of the people that are involved. So there's me, Sir Arthur Eddington, Andrew Carmelin, and Charles Davidson. So I helped aid Sir Arthur Eddington in setting up his experiment, and we did this in Principe Island off the coast of Equatorial Guinea. And then Andrew Carmelin and Charles Davidson, that was like the second team, and they helped set up the experiment, their own experiment in Sabra, which is north of Brazil. But the overall theory that we were testing, that was Einstein's theory, and it was the theory of general relativity.
Okay, so like what impact did your project have on the physics community?
Well, our findings helped prove Einstein's general theory of relativity, and this had a huge impact on the physics community as a whole. Well, in fact, we were published in the headlines of newspapers that we helped prove that Einstein's theory was correct, and that in fact light can bend around massive objects. So by proving Einstein's general theory of relativity, we made it known that gravity was not just some mysterious force that was commonly thought of as. It was actually a result of a massive object warping the space around it. This is currently the best explanation we have to explain gravity and space-time. So it's that this object, you can think of this object as like being on like a warping like a sheet of paper. Like it sits on it and it like pushes the paper down, and then when you have objects around it, they will fall towards the object in the middle. So that's what pretty much we helped prove. We helped prove that Einstein was in fact correct.
Okay, so did anyone in the scientific community doubt the validity of your experiment?
Well, in fact, yes, there were. There were a few people who believed that I and Sir Arthur Eddington had made a mistake in our experiment. Well, this might be because it was kind of a crazy idea, Einstein's general theory of relativity. So a lot of people doubted it at first because it was so weird to think about. But eventually, the scientific community acknowledged the results that we got and came to believe that Einstein's theory of general relativity was in fact correct.